Hi, this is Dr. Joannides, Chief Medical Director at Optimum Re, and this is the Optimum Academy. We're talking about a new alcohol marker, 101, video number 2, PEth, phosphatidylethanol. So let's get started. So what is PEth? PEth is a new ethanol marker that actually reflects ethanol use. It's not a proxy, it's not a maybe. If it's elevated, the applicant is ingesting ethanol. PEth is formed on the red blood cell membrane when a person ingests ethanol. So let's take the PEth journey. So in our last video, we talked about the red blood cell and how many trillions of red blood cells we have in our body. And this unique cell is able to flex and get through tight spaces to deliver oxygen and take away carbon dioxide from all areas of the body. So the red blood cell is quite a unique cell. And there's a lot of activity going on each of the red blood cells' cell membranes. And specifically in the red box, I highlighted this phospholipid bilayer membrane. That's where the action is going to be concerning this new ethanol test. So let's dive in. So we know about hemoglobin in the red blood cell. That makes up most of the volume of the red blood cell, hemoglobin, and that's how the oxygen is distributed from the lungs to the body in the red blood cells. But we know about glucose can attach to hemoglobin in the red blood cell and form glycohemoglobin, and we can test that with a hemoglobin A1C test. So we're familiar with that. So we know that the red blood cell carrying hemoglobin can attach to glucose and form glycohemoglobin. So let's imagine we're at Typhoon Lagoon on vacation and we're in an inner tube, and we're going to use those inner tubes just as if that was a red blood cell floating through a capillary or a vein or an artery or whatever. So we're going to pretend that the inner tube that we sit in as we float along down the path is a red blood cell. And red blood cells last about 120 days in the body, so they get recycled. So the average red blood cell has a 120-day lifespan. So as we said, each red blood cell has hemoglobin. That makes up most of the volume of a red blood cell. And each red blood cell contains about 270 million hemoglobin molecules. That's a lot. And it makes up about 90% of the red blood cell's volume. And it can be measured by the mean corpuscular hemoglobin, or MCH, on a CBC. So if you eat sugar, glucose attaches to the hemoglobin in the red blood cell and raises the A1C. So it's a good test. It gives us a perspective over 2 to 3 months over what the glucose level has been in the body. And so we've used it very effectively for many years to give us an idea of what has been the glucose experience of the applicant applying for life insurance, and are they at any risk for diabetes due to an elevated A1C level. But today we're going to talk about a new alcohol marker, PEth, which is short for phosphatidylethanol, which is a long word, and we're going to talk about what this means. And it's going to help us indicate how much alcohol the applicant has ingested. So let's take a look again at the red blood cell. Now, we're not going to be talking about hemoglobin, which the glucose attached to. We're going to be talking about that membrane of the red blood cell as we talk about this new alcohol marker, PEth. So here's what phosphatidylcholine looks like in the red blood cell membrane. So in the membrane that wraps around the red blood cell, there's this ingredient called phosphatidylcholine. So let's take a close look at it and get in the weeds a little bit. And you'll notice that it has this long tail of 2 long fatty acids. And these fatty acids are hydrophobic, meaning they don't like water. On the other end is the choline end. That's what gives it the phosphatidylcholine part. And the choline likes water. So that's what we call hydrophilic. In other words, the choline loves water. So we have one end of this molecule that hates water and one end that likes water. So it's kind of like if you looked at a bottle of salad dressing, the fat floats to the top, and that's why you have to shake up salad dressing when you want to use it after you take it out of the refrigerator, because the fat separates from the water part and floats to the top. So if that's balsamic vinegar mixed with oil, the oil floats to the top and the balsamic sinks to the bottom. So we're going to kind of turn it 90 degrees so that we have the fat on one end, just like this phosphatidylcholine that's in the membrane of the red blood cell. And then the choline part that likes water is the balsamic part, and that's on the other end. So if everybody's with me, we're just kind of looking as one end hates water and one end, the choline part, likes water, and this is in the membrane of the red blood cell. So we're going to stick that phosphatidylcholine right into where that phospholipid bilayer membrane is in the red box. So it's kind of like we take this molecule and stick it right in to the cell membrane of the red blood cell. The part that hates water, that hydrophobic end, is on the inside of the red blood cell, and the part that likes water, the choline end, is on the outside of the red blood cell, which is great because blood is mainly water-based. So this allows the red blood cell to float around in the water because the outside is covered by an area that likes water. So we have fat on the inside, choline part that likes water on the outside of the red blood cell membrane. So that's what phosphatidylcholine does in the red blood cell membrane. So before we talked about the hemoglobin attaching to glucose, now we're just sticking this phosphatidylcholine in the cell membrane of our inner tube, like as if we were in the red blood cell, which is the inner tube, floating down Typhoon Lagoon. Now, if you ingest any ethanol, alcohol, beer, wine, or spirits, or if you even have any cough medicine or NyQuil or mouthwash, mouthwash has especially a lot of ethanol or alcohol. Ethanol is a small molecule. It looks like this. Those two blue balls are carbon atoms. The red ball is an oxygen atom, and the white balls are hydrogen atoms. So ethanol is a small molecule, and it can be in a lot of different things that people drink. And we're going to talk about what happens when you drink alcohol. So on the red blood cell, we said that there's phosphatidylcholine in the membrane. But when you drink ethanol, what happens is the ethanol attaches to the phosphatidyl part of the molecule and kicks the choline off. And that phosphatidyl part with ethanol attached to it is called phosphatidylethanol in the green box. And that's what PEth is, capital P, capital E, TH. So ethanol changes the phosphatidylcholine to phosphatidylethanol, and that's what PEth is. So it's as if in our inner tube we had the phosphatidylcholine. Now the choline part's kicked off and the ethanol attaches. Now the phosphatidylethanol doesn't last as long as the A1C test does on a red blood cell. The half-life is usually 4 to 10 days. So considering all things, this phosphatidylethanol test probably gives us a 28-day scan of how much alcohol the person has used in the last 28 days. So not as long as an A1C, but still gives us a fairly long period where we can assess how much ethanol the person has ingested in the last month. So now we have, when someone drinks ethanol, that ethanol attaches to where the choline was, and we have phosphatidylethanol. So it's sort of like the A1C, but it's actually taking place in the membrane instead of attaching to the hemoglobin in the red blood cell. So the phosphatidylcholine reacts with ethanol to form phosphatidylethanol. The red blood cells have a lifespan of 120 days, but the membrane is an active area of the red blood cell, and we only have about a 28-day window for this particular ethanol marker. And here's how the lab test would be reported in the red box. And you'll notice it says reference ranges. And then there's two PEth results. PEth, and then there's these funny numbers after it, 16:0/18:1, and that's called capital P, capital O, capital P, capital E, TH. And the normal range is less than 20 nanograms per milliliter. And then there's another PEth called PEth 16:0/18:2, and that's capital P, capital L, capital P, capital E, TH, which is also in normal range less than 20 nanograms per milliliter. So if you ordered a PEth test, these are the two things that you might get back. And if the level was less than 20, basically it would suggest that this particular person is not using any ethanol and they're abstinent. So why do we have two different kinds of PEth? And we'll be talking more about that, but the first one that I mentioned accounts for about 37 to 46% of the PEth result. And the second one accounts for 26 to 28% of the PEth result. Sounds a little confusing, but stick with me and we'll get to the details on what this actually means. The PEth test is stable for about a month, as I said. Women have higher levels of PEth after drinking equal amounts of alcohol as men because they have fewer red blood cells. We said women have about 25 trillion red blood cells, whereas men have 30 trillion on average. The CDT test could be negative, but we could still have a positive PEth test. Now, here's a study that was done to give you some idea of how much alcohol causes elevation in PEth tests. So it's a little detailed, but stick with me and we'll get through this. The men's result were reported in blue. The women's result was reported in pink. So, as we said, the level of 20 nanograms per milliliter over there to the left with the long line and the red arrow. If levels that are detected in the blood are less than 20, the person is unlikely to be drinking any alcohol. But this test was done, and people drank the same amount of alcohol, both men and women drank the same amount of alcohol for 21 continuous days. Then they stopped. At the top is the group that drank 1 drink per day. The second group drank 3 drinks per day. The third group drank 4 drinks per day. And the fifth group drank 6 drinks per day. You can see in the colored zone that the PEth levels went up as over the 21 days to peak out on the 21st day. Now, in that group that drank 1 drink a day, you can see where the 20 nanogram per milliliter level is. And all groups exceeded that. Women were had substantially higher levels than men did, even drinking 1 drink per day. Now, over to the far right is what we're calling the cutoff, the Swedish cutoff, or 215 nanograms per milliliter, approximately. And that's what we're going to call anything over those lines that the green arrows are pointing at, we're going to call that excessive alcohol use. So if someone is drinking 1 drink per day, either men or women, they exceed 20, but they don't exceed the 215 Swedish cutoff level. However, when people drink 3 drinks a day, you can see that both men and women exceed the 215 nanograms per milliliter, or the Swedish cutoff. The same holds true in even higher amounts when people drink 4 drinks per day for 21 days. And then you can see how high the levels are when people drink 6 drinks per day. So if someone is reported as less than 20 nanograms per milliliter, they're probably not drinking any alcohol. But if they exceed 215, or approximately in the 200 range, they're probably drinking more than 1 drink per day. So this is important and useful information to us when we try to assess how much alcohol any one person or applicant might be drinking. So this is kind of a spectrum of values on how to interpret PEth values. Less than 20 is compatible with abstinence over to the left. 20 to 200-ish is compatible with social drinking. But over that 220, 215 cutoff, that's compatible with chronic and excessive alcohol consumption, and the levels may go up into the thousands. So that gives us some idea of how much alcohol that applicant may be using. And again, talking about the actual results, we have 2 different types of PEth. The first one, as I said, we usually use those numbers of less than 20 and greater than 200-ish. The second one sometimes is just used as a confirmatory test that PEth is present. So it may be that the first one, the POPE PEth test, is the one that's actually used for the numerical rating, and that the second one is just a confirmatory test to make sure that the test is valid and accurate. Now this is a graph that shows if somebody stops drinking, what would you expect to happen to the PEth levels? And they should decrease over time, and those blue zones show that in terms of length, in terms of days after stopping drinking, how the PEth level should reduce in a particular way. So that kind of gives you an idea of what you would expect in the decreased levels of PEth over time. If you, say, took a blood sample each day, the PEth level should be going down. But if you look at that red arrow, in that person, the level is not going down. So that would give you an idea that even though this person may say they've stopped drinking, that their PEth level is remaining high and that they're actually still drinking alcohol. So this may be useful in certain circumstances that we'll talk about. So where would we use PEth tests? So we can certainly use it in underwriting ethanol risk. We certainly have a lot of people where it's a little cloudy on exactly how much alcohol they're drinking. We could use it in determining causes of death and life insurance claims. We could use it in fetal alcohol spectrum disorders, fetuses that are exposed to mothers that drink alcohol during their pregnancy. We could use it in situations where somebody is up for a liver transplant. Have they stopped drinking alcohol in preparation? And we can use it in all kinds of other forensic applications, workplace testing, and driver's license re-granting if somebody's had DUIs and they're still at risk for drinking under the influence of alcohol. So that completes video number 2. Stay tuned for video number 3 to continue our series on PEth, a new alcohol marker.